Hi everyone, I'm Christina, and in this A-level mathematics video, we're looking at inverse functions, part 1. The objectives of this video are to define an inverse function denoted by f to the minus 1 of x, and to understand that the inverse of a function only exists if the function is 1-to-1. So let's first start with the definition for an inverse function. An inverse of a function f to the minus 1 of x undoes the original function. So it's swapping the inputs with the outputs. We can look at an example of this. Let's say our function f of x is equal to 7. It can be any function you want. If we apply its inverse function, which will be f to the minus 1 of x, let's try doing that by applying it to both sides, as we usually would. Now, on the left here, we're doing the reverse function of the original function f. And so what happens is f to the minus 1 of f of x just gives you your original input x. So you get back to the original value of your domain. And on the right-hand side, we're just doing the inverse function f of 7. And so now you can see 7 becomes your new input when originally it was the output of your function. But it is now the input of your inverse function, and x is your new output, even though originally it was the input of our f of x function. So this can only work if every output maps from exactly one input. So this is our definition of a 1-to-1 function. If you have two distinct inputs and they give you the same output, if we try to apply the inverse function, we wouldn't know which input to go back to. So if we had two values in the domain that gave the same range, if we then try to find the inverse, if we try to apply the inverse function of that range value, we don't know exactly which domain value we should go back to. So that's why the function must be 1-to-1. And we can illustrate that a little bit here. So we can see that each value in our domain, we have x, y, z, maps to one unique value in the range when we apply f of x, shown in black. And then we can also apply the inverse function on the range to get back to the domain. And we can see that in red. But this can only work if each distinct value in the domain maps onto one distinct value in the range. Otherwise, we can't find an inverse function.